com. So today we're going to go on the number one news items for today. And what we have is a new technology from Purdue. This is a process they're trying to patent, where they're found a novel wet mixing way of mixing in conductive particles into filament, and doing that in a really nice organized way to make kind of smarter 3D printed parts. So what they could potentially do with this is mix in conductive elements to have, for example, temperature sensors or strain sensors, or to make the entire 3D printed part into a strain sensor. And they do this, and well, you can see it ahead of you in the image. They're essentially mixing conductive particles, and they're using a really low-cost Philobot to do this. And they have managed to do this in a certain way to make coherently conductive components, 3D printing components. They use two 3D printing methods. They've done a couple of experiments, a couple of papers on this. One is on a PVDF film, it's FDM, essentially, or material extrusion on a PVDF film. And then the other one is this is then put between two direct ink writing made silver electrodes. The printers use, actually, all this stuff is for super low cost. They're using a really low cost Philobot extruder. They're using a MakerBot Replicator 2X. And also using a high roll Hydra 16A, which is a really, really nice printer for the DIY, well, it sounds a bit weird, but the DIW, direct ink write step. It's a new technology. They're trying to patent it. They're basically telling us that it exists, but they're not exactly telling us, Purdue's not exactly telling us how this works. It's been done by Brittany Newell, Cole Minor, and Julio Hernandez, a bunch of other people, and hopefully they'll commercialize it, because this could be a very low-cost way to put a strain sensor on a 3D printed component to measure the component's effectiveness, put a temperature sensor on it, or to add a temperature and strain sensor that's custom made to a light post or something like that. This could be a very broad applications if it works, and if it's scalable, of course. But so far, it's very, very promising. The next bit of news is, actually, one thing I do want to say a little bit more about this is another point of this MEMS 3D printing thing that I'm all about. This whole idea of being able to create parts with electrical conductivity, or parts with electromechanical properties. We could also see this as a method to making MEMS-like parts that can be 3D printed, which I think is a very important thing. I just forgot to say that. So the next thing is from MIT, and MIT is going to space. There's on Black Box 2, which is a kind of remote-controlled experiment set up on the ISS, made by NanoRacks. The MIT's Media Lab is going to be conducting an experiment, and these are extrusion-based experiments. And what they're doing on board the ISS is essentially they're extruding liquid photopolymer into a gel-like material, into kind of like a sack-like structure. And these are pre-made flexible forms. So essentially, they're extruding the photopolymer into a pre-made form, and these pre-made forms could differ. Now, what they hope is that in a microgravity environment, they'll get better results than on Earth. So what's the idea? In normal gravity, of course, if you extrude something, it's going to at one point sag under its own weight, or the structure is going to collapse. And the idea is, using microgravity, this experiment may be able to create thinner walls, or more delicate or longer structures than could be made on Earth. Now, a lot of the excitement about 3D printing in space is the fact that space is kind of the way, or 3D printing is the way to extend your mission, is to have an improvised new part, or to print a skin patch for an injured astronaut, or to print a new engine component, or to upgrade stuff on the go, or to use food packaging to make something to make a spacecraft better. But there's also another thing that's not as prominent in the news, and Made in Space and other companies have been doing stuff on this, and fiber optics and also been trying to do some bioprinting. And that's the idea of in-space production. So the idea that space, this unique environment of space with this microgravity that we get above these space stations, could be a place where we could make things more efficiently than we can on Earth. Like, for example, a heart. We could make it to a certain degree on Earth, but in microgravity, maybe we could make that heart better. Or maybe we can make that fiber optic cable better in space. This is also what MIT is looking at here. So this is potentially very disruptive, because it could mean that a space station could be powered, if you will, or funded, perhaps privately by private money through doing something extremely high value in manufacturing. Now, of course, we have to launch something in space would even be $10,000 or more a kilo. To land it coherently would also cost money. So it'd have to be a very extremely expensive, extremely desirable item. But if you would have a space station, be able to fund it through 3D printing heart tissue or something like that, something really high value, then that would be extremely disruptive to the space economy and could really change how things are manufactured here on Earth by having an in-space manufacturing option. So these are kinds of experiments that we should be watching. The next thing is also by NASA actually, and that's ICON NASA. NASA is giving 57.2 million to ICON to build space-based construction systems. The idea is to build structures on the moon. The project is called Project Olympus, and the idea is to have a large-scale 3D printer capable of constructing moon bases, or things like a landing pad, or things like a really basic kind of setup to initially let people explore space, roads, things like that. So the initial construction, so maybe not your final moon base, though of course they're hoping to do that, but maybe some coherent structures that would help you print that. This is a 6-year contract, and the idea is to build this Olympus construction system and then use the lunar regolith, the materials on the moon, to build things on the moon. Now, previously, NASA had a big competition. They had a Mars Dune Alpha surface habitat that was partially made by ICON for a large-scale simulation mission, and ICON did really well on this as well. And now they're getting an off-Earth contract. Now, ICON has already raised a ton of money, is already working with some of the largest home builders in the world to build structures. Now they've got the space thing as well. So, that begs the question, like, is construction becoming 3D printing construction, which looks very kind of crazy, lots and lots of companies, and becoming kind of a 3-horse race. In Europe, we see Cobalt becoming very big and very trusted, having a lot of the right partners, from Perry to cement companies and all this. And it's becoming like the choice for a lot of on-site construction 3D printing project. Meanwhile, Weber B-Mix is spitting out lots and lots and lots of actual real-made things like stairs and other kind of structures. So they're doing really well in getting accepted and building things in the real world. And then ICON, of course, with all this money it has, is going to do well. So it seems like it's shaping up the 3D printing construction is kind of beginning to look maybe like a 3-horse race between Weber B-Mix from the Netherlands, Cobalt from Denmark, and ICON from the States. So that could be quite remarkable if that would be already the case. Or is it too early to tell? I'm not entirely sure yet. But thank you so much for your time today. My name is Joris Peels, and this is another episode of 3D Printing News Unpeeled. Enjoy.